Okay, Rick. Well, we're all set down here. We got about 9 minutes of work left to get this program back into space. We'll keep a close eye on things during that time, and we'll be with you all the way.
Thank you, Bob. We're sure looking forward to it.
Launch Director Bob Seek giving a message to the crew and an answer from Commander Rick Hauk. The clock will resume in just 5 seconds from now. 3, 2, 1, T-minus 9 minutes and counting. The countdown events are now being controlled by the ground launch sequencer from now until the T-minus 31 second point, when we begin the switch over to the onboard redundant set launch sequencer. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back to the LPS system that the commands have been executed. 8 minutes 30 seconds and counting. The primary job of the onboard computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are normal and staying within their prescribed limits.
And Flight OTC, I'd like to have you proceed with the transmission of the stored program commands.
Coming up the 8-minute point, T-minus 8 minutes and counting.
Flight OTC.
The Orbiter Test Director has requested that Houston send the stored program commands, which is the final update on antenna management and frequency changes. This ensures that the orbiter has the latest information to speak to various ground tracking stations as it circles the Earth.
Roger. Flight, proceed with the transmission of the stored program commands.
T-minus 7 minutes, 30 seconds and counting, and the ground launch sequencer has started retracting the orbiter crew access arm. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds.
Okay, we copy.
T-minus 7 minutes and counting. The orbiter access arm moving away from the orbiter now into its park position. T-minus 6 minutes, 30 seconds and counting. Pilot Dick Covey will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power units, or APUs, at the 6-minute point. This consists of positioning a number of switches and verifying that they're in the proper position, then throwing the 3 propellant isolation valve switches, which allow the hydrazine to start flowing towards the APU.
I'd like to have you perform the APU pre-start. APU pre-start didn't work.
We've passed the 6-minute point, T-minus 5 minutes, 54 seconds and counting.
OTC, PLT, APU pre-start's complete. Pre-grade talkbacks.
Copy.
T-minus 5 minutes, 30 seconds and counting. Mission Control has transmitted the signal to start the onboard flight recorders. The 2 recorders will collect measurements of shuttle systems during flight and be played back afterwards. At the 5-minute point, the orbiter test conductor will ask pilot Dick Covey to start the auxiliary power units, which provide hydraulic power for steering and controlling flight surfaces. T-minus 5 minutes and counting.
Let's go for orbiter APU start. And PLT, perform the APU pre-start.
Roger, and work.
Pilot Dick Covey now is flipping the 3 switches in the cockpit to start each of the 3 APUs. The liquid oxygen replenishing of the LOX tank has been terminated at this point, and the liquid oxygen fill and drain valve is closed. 4 minutes, 30 seconds.
You see the APUs are up and running.
Copy that.
The auxiliary power unit's up and running according to pilot Dick Covey.
CDR, reconfigure heaters.
Roger, that's complete.
Coming up on the 4-minute point in the count. The crew has would normally close their visors, but will delay that. The main engine final purge sequence is underway. The orbiter flight control surfaces, such as elevon, speed brakes, and rudders, are now being moved through a pre-programmed pattern to verify that they're ready for launch. T-minus 3 minutes, 30 seconds. All 3 engines now being moved in a pattern to verify their readiness to support the ascent flight control. After going through their paces, they'll be aligned to their start positions. We're coming up on the 3-minute point in the count at T-minus 2 minutes, 55 seconds. The start of the external tank liquid oxygen pressurization will begin. 3 minutes and counting. And the gaseous nitrogen purges of the main engines will be terminated.
Go for ET-LO2 pressurization.
The ground launch sequencer has started to retract the gaseous oxygen vent hood or beanie cap on the external tank.
I'd like to have you clear caution warning memory and verify no unexpected errors.
The computers will make a final check to ensure the vent arm is fully retracted at the 37-second point. T-minus 2 minutes, 30 seconds and counting. Ground supplies of hydrogen and oxygen for the orbiter fuel cells has been turned off. Discovery is now running on its onboard reactants. Coming up on the 2-minute point in our countdown. T-minus 2 minutes and counting. Liquid hydrogen replenish of the external tank has stopped and pressurization to flight level is underway. The vehicle is now isolated from all ground propellant and fluid loading equipment.
Roger, that's complete.
TLS's go for ET-LH2 pressurization.
T-minus 90 seconds and counting. Less than 2 minutes away from the launch of STS-26 and its crew of 5.
1 second, failure.
And we have heard that the clock will hold at 31 seconds.
And TDRS-C, it's a cabin pressure rated change. Okay, copy. ECL.
We're anticipating the clock will hold at T-minus 31 seconds due to a failure. We have not heard what that is yet.
It's going down. Probably due to the increase in the O2 going in from the suits. Okay, and with your concurrence, we'll clear the air and proceed.
T-minus 50 seconds and counting. We're going to clear the air and proceed. Had a concurrence from the launch director to proceed.
And if we clear, we will not stop at 31. Is that true? That's correct, NCD.
We will not stop the clock. The orbiter computers have positioned the vent doors, T-minus 31 seconds. We have a go for auto-sequence start. Discovery's 4 redundant computers have approved. T-minus 23 seconds and counting. The SRB nozzle profile. T-minus 15, 14, 13, 12, 11, 10. We'll go for main engine start. 7, 6, 5, 4, 3, 2, 1.
3 nautical miles.
Discovery, going throttle up.
Discovery given a go at throttle up, 3 engines at 104%. Velocity 3,200 feet per second, altitude 10.8 nautical miles. Downrange distance 8 nautical miles. Seconds from solid rocket booster separation. 1 minute 45 seconds. 3 engines at 104%. Velocity 4,800 feet per second. Altitude 20 nautical miles. Downrange distance 19 nautical miles. Standing by for solid rocket booster separation. Solid rocket boosters have separated. 2 minutes 20 seconds. 3 engines still running 104%. 5,600 feet per second velocity, 31.8 nautical miles. Altitude, downrange distance 38 nautical miles. Three APUs still running at normal speed. 3 good fuel cells. We'll be hearing some call-ups here shortly from the Capcom about the capability to reach transatlantic sites. Velocity 6,200 feet per second, altitude 41 nautical miles, downrange distance 60 nautical miles.
Discovery, 2-engine Marone.
Roger.
That call-up indicating Discovery may be able to achieve a transatlantic abort at Marone if that were to become necessary. Return status and mission control positions all report go. 3 engines still 104%. Velocity 7,600 feet per second. Altitude 53 nautical miles. Downrange distance 107 nautical miles. Standing by for negative return.
Discovery, negative return.
Negative return.
That call-up indicates Discovery now can no longer turn around and return to the launch site in the event of an abort. 4 minutes 20 seconds. Velocity 8,700 feet per second. Altitude 59 nautical miles. Downrange distance 148 nautical miles. Standing by for press to ATO call.
Press to ATO, select Banjul.
Work out.
Call-up indicates Discovery could reach an abort to orbit on 2 engines if that were to become necessary. 5 minutes 3 seconds. Velocity 10,300 feet per second. Altitude 65.7 nautical miles. Downrange distance 203 nautical miles. Standing by for a press to MEGO call.
Discovery, press to MECO, group Banjul 109.
Roger.
Crew given their press to main engine cutoff call, indicating they can proceed to normal main engine cutoff on 2 engines if that were to become necessary.
Discovery, performance nominal.
Roger, nominal.
6 minutes, 10 seconds. Velocity 13,900 feet per second. Altitude 68 nautical miles. Downrange distance 323 nautical miles.
Discovery, single engine Banjul 104.
Roger.
That call-up indicates Discovery could achieve a single-engine landing at Banjul if that were to become necessary. Banjul, one of the transatlantic abort sites. Minutes, 50 seconds. Velocity 16,400 feet per second. Altitude 66 nautical miles. Downrange distance 405 nautical miles. Guidance officer reports good navigation aids, and main engine cutoff is expected at 8:33.
Discovery, single engine press 104.
Roger.
Discovery's crew told that they can press on the main engine cutoff in the event of a 2-engine failure. 3 engines running at 104%. 3 good APUs, 3 good fuel cells, velocity 20,000 feet per second, altitude 61 nautical miles, downrange distance 527 nautical miles. Engines beginning to throttle now to maintain 3 Gs. Mark 8 minutes, velocity 22,500 feet per second, altitude 59 nautical miles, downrange distance 619 nautical miles. At about 82% throttles now, maintaining 3 Gs on the vehicle. 10 seconds away from main engine cutoff. Velocity 24,600 feet per second. Altitude 59 nautical miles, downrange distance 700 nautical miles. Standing by for main engine cutoff. Main engine cutoff confirmed. Discovery's 3 main engines have now shut down as programmed.
Discovery, nominal MECO, ohms 1 not required.
Normal main engine cutoff has occurred now.
Okay, thank you, Houston.
Crew informed that ohms 1 is not required. There'll be an ohms 2 to round out the orbit at the expected altitude. Standing by for external tank separation.
Discovery, your go for APU shutdown on time.
Roger.
APUs provide hydraulic power to operate the aerodynamic services and to gimbal the engines.